Today we're going to look at lesson 3, and as promised from yesterday's lesson, I told you we were going to talk more about circumference. So one of the things in the notes on your handout yesterday was the formula, the equation that we use for circumference. And today we're going to talk about that. This is a great lesson. It's such a good tie-in to what we were just doing with proportional relationships in Unit 2 and Unit 1. And we've got a couple of learning goals. The first is that we describe the relationship between circumference and diameter of any circle. Remember, circumference is that distance around the outside edge of a circle, kind of like perimeter. Diameter is the distance across the circle through that center point. And we're going to be able to explain what pi means. Now, pi is often shown with a symbol here. So please get used to that. That's what we're going to use most of the time instead of the actual word pi, pi. We'll be using this Greek symbol to represent it. Now let's get into the lesson today. So we have several circular objects. Now this would have been much better if we could actually measure these objects for our lesson today, but instead we're just going to look at some measurements and just imagine different circular objects. It doesn't matter what it is. It could be a paint can, it could be a bowl, it could be the lid to a container, anything that we're looking at, even well, I was going to say a basketball, but we'd have to be careful how we measure that basketball because the basketball is actually a sphere. But we have a table filled with some measurements, and we have an empty graph here, and it wants us to plot on the coordinate plane here on the graph these points. So you can see that our x-axis is labeled as diameter, our y-axis is labeled as circumference. So I'm going to get those points here from my table with my x and y value. Look closely. Now, if we were actually measuring these objects with, say, a flexible tape measure, we would not be measuring something to 0.25 centimeters. So this is way more precise than we actually would be able to be in real life, and that's going to help with kind of what we're trying to demonstrate here today. But imagine that this first object had the diameter measured. And remember, let's draw a quick reference here. So if this is our circle, the diameter is going through the center point from edge to edge of the circle, from side to side of the circle. And then the circumference is the wrapped measurement around the entire circle. So those are our two measurements here of object 1. We're going to find 12.5 on the x-axis, 39.25 on the y-axis, and we're going to have to do some estimating here because looking at our intervals, these are not nearly precise enough to be exact with our points. So if we go to 12.5, each of these vertical lines is 1. So we'll go between 12 and 13, and then up to just below 40 is where we're going to be for our circumference. So we'll make a marking right about there. Okay, and again, being as precise as we can, trying to get close to that. Now let's look at object 2. The diameter is 22 centimeters and 69.08 centimeter circumference. So 22 up to about 70 again. Would put us right here. Boy, this is really tough to be precise. For object 3, we've got a much smaller circle. You can see the diameter is only 3 centimeters for object 3, and about 9.5 centimeters for the circumference. And then finally, a diameter of 5.5 and circumference of about 17. So we'll put that point there. Okay, now we plotted the points. It does look like those points are pretty close to forming a straight line. And remember, we talked yesterday about a proportional relationship that because it was actually measured and not calculated, there could be some error. We're trying to put points on a graph that isn't nearly detailed enough to be precise where we're placing these points. So we're doing the best that we can, but to me, this looks like a straight line. I could connect to the origin here and pass through those points, or pretty close to it. Now, if I look at this table and these measurements, remember I can find the constant of proportionality by dividing y by x. That comes from our equation that we've been using for proportional relationships, but y divided by x equals k, or my constant of proportionality. And if I were to divide each of these circumferences by the diameter of that specific circle, I would get, in this case, exactly 3.14. 3.14 for all four of those examples. Now, that is an incredibly important number and what we're going to be talking about today. 3.14 is the start to this number that we mentioned back with our learning targets as the number pi. So that's approximately, this isn't actually equal to pi, and I'll explain that here in a second, but approximately is this wavy equal sign. Because pi is an unending number. It's a number that will never end. The decimal goes on forever and ever and ever and ever. And they are still trying to find a computer powerful enough to calculate the remaining digits of pi. And so far, I don't know to the exact place they have gone, but it's a lot. A lot of numbers, and people have memorized many of these digits in that decimal number, and we still don't know the end of it. So, for the most part, and for most of our calculations in 7th grade, we're going to round pi to this 3.14 here. Whenever you hear pi, you can think it's about 3.14. And being that this is the constant of proportionality between diameter and circumference, that's really cool. So we actually have a proportional relationship, and this will work with any circle. You can go home and try it. So find a circular object, measure the diameter, measure the circumference of that circle, and I guarantee you the circumference of that circle is going to be about 3.14 times bigger than the diameter. It works always. It's really cool. So that is a proportional relationship. So when we look at this next activity, we're given a table. Some of the diameters are filled in, some of the circumferences are filled in. But now that we know it's a proportional relationship, we have a constant of proportionality. It's equal to pi, which again, we're going to round for today's activities to 3.14. So if we multiply by 3.14, we'll find the circumference if we're working with a diameter. If we multiply by that, if we divide or multiply by the reciprocal of 3.14, we will get from a circumference back to a diameter. And we can fill this in and give it a try. So 3 centimeters as the diameter multiplied by our constant of proportionality here, 3.14, will give us the circumference. So that first circumference would be, and this is approximate because we're rounding our constant of proportionality here, it's going to be approximately 9.42. If we do that for a diameter of 10 centimeters, multiply that by 3.14, we would get 31.4. And now for the next two circles, we are told what the circumference is. We need to work backwards. We need to divide by pi or to multiply by the reciprocal of pi to get that diameter. So 24 divided by 3.14 is 7.64. 18, a circumference of 18 would be 5.73. And then this one should be obvious because we're comparing to one of something. 1 centimeter in the diameter, this is our unit rate, is going to be 3.14 centimeters of the circumference. Okay, that being our unit rates, which we've already talked about, gives us that constant of proportionality that we're rounding to 3.14. Okay, really, the constant of proportionality here is pi. Okay, let's take a look at the summary. This kind of clarifies what I'm talking about a little bit, and we're going to keep this idea going certainly for a while in Unit 3. But it says for any circle, and we've got a few shown here, for any circle, there is a proportional relationship between the diameter of the circle and the circumference. The Greek letter pi stands for that number. That's the constant of proportionality, the k value between the circumference of a circle and its diameter. Now, here's the cool part. So remember, for proportional relationships, our equation that we were always trying to model was y equals k times x. Our x and y values were often in a table or on a graph, and this k, this constant of proportionality, was how it was changing. Now look at this. It says if d is the diameter of the circle and c is the circumference, then we can use this equation to solve. So we can take c equals pi times diameter. Now remember, pi is a number. It's our k value, our constant of proportionality between diameter and circumference of a circle. So this mirrors that equation that we've been trying to create for proportional relationships. And this hopefully shows you how pi is that constant of proportionality that we'll be using here. Okay? Let's do a little problem solving. Now for this activity, it says select all the pairs that could be reasonable approximations for the diameter and circumference of a circle. Now, being what we just talked about, if we had a table set up and we were comparing the diameter to the circumference of these circles, all right, and we had for A, 5 meters to 22 meters. Now these are all different measurement units, but that's okay as long as it's the same between the diameter and the circumference. So we have 19 inches for diameter, 60 inches for circumference, and then lastly, 33 centimeters and 80 centimeters for the circumference. Now, being that we know our constant of proportionality is about 3.14, in order for it to be a reasonable approximation of the diameter and circumference, our circumference is going to have to be about 3 times bigger than our diameter. So looking at these 3 circles, or supposed circles, which one has a circumference that's about 3 times the diameter? Well, if we look at this first one, 5 times 4 is 20, so it's even times more than 4. That's meaning that the circumference is too large for a diameter of 5. That would not make a circle. If we look here, 19 is about 20, and 20 times 3 is 60. That's pretty close to being 3 times greater than the diameter. I think that's a very close contender, but let's check this one also just to try to be sure. So 33 times 3 is 99. This circumference isn't big enough to be the circumference with a diameter of 33. That one wouldn't work either. So just by estimating, I can see this is the only reasonable measurement for a diameter and circumference of a circle based on my constant of proportionality 3.14. Now, we have three problems that we're going to do together. The first three problems on the back of your handout today. I would like you to try the rest of them on your own, and it's using the skills that I'm going to be showing you here. So if you pay close attention for the three that I do, basically you're going to be doing some version of that again with different numbers. Let's remember here at the top, the formula for circumference, remember, that's mirroring that y equals k times x. We're just going to use different variables. Instead of y, we're going to use c for circumference. Our k value is pi, and we're going to multiply that by our other amount, which is going to be the diameter of the circle. Just remember, for most of the time, and for today this is also true, instead of pi, that unending decimal that goes on and on and on and on and on, we're going to round it to the first three digits, 3.14. That's what we're going to use as our constant of proportionality today. So it does also tell us that we're going to round our answers to the hundredths place. So we don't need long, crazy long, ridiculous answers. Let's just go to the hundredths place. Remember, that's 2 place values to the right of the decimal. We're going to round to that for all of our answers. So for number 1, Jalen is making a circular pizza with a circumference of 44 inches. What is the approximate radius of Jalen's pizza? So we've got our key information here. We've got circumference of 44, and it wants to know the radius. All right. Now, if we're talking about our proportional relationship, remember, we're comparing diameter and circumference. In no place here do I talk about the radius. So that's going to be an extra step we need to think about here at the end. Now, I'm going to show you in a table. You certainly don't have to create a table, but this is where our formula, our equation is coming from, is this proportional relationship that you've seen many, many times. So I have a circumference of 44 inches. So that's on the right side of my table here. To go to the diameter, I need to get about 3 times smaller. So I'm going to divide by my constant of proportionality, which we're rounding to 3.14. Now, 44 divided by 3.14 is a long number. Remember, we're rounding to the hundredths place. So it's 14.012. Now, I only want 2 place values there, so I'm going to look at that third decimal place and decide if this should round up or stay as it is. So I have 0, 1, and that third number is a 2. 2 isn't enough to tell me to round up to 0.02, so I'm just going to get rid of it. That's rounded to the hundredths place. Now, remember, that's diameter. Diameter goes all the way across the circle. So my diameter here goes all the way across. My radius is only from the center to the outside edge. It's half of the diameter. So if my diameter is about 14, then my radius is about half of that. It would be 7 inches. Let's look at another one. Paige wants to sew lace around the edge of a round tablecloth. The tablecloth has a diameter of 6 feet. About how much lace will Paige need? first we need to figure out what we need to calculate here. So if we're sewing lace around the edge of a round tablecloth, to me that sounds like we're finding the circumference. So we're given the diameter of 6 feet. I need to use my equation here. I could make another table if I was more comfortable with that, but my circumference is equal to pi times the diameter, 3.14 times d, diameter. And my diameter is 6 feet. So I'm just going to replace my variable that I know with 6 feet. I'm going to take 3.14 times 6. That's going to equal what my circumference is, and that is 18.84. That would be still the same measurement unit, which is feet. And if I look at my answer choices, it looks like they've been rounded to the nearest foot. So the closest answer, of course, would be B, 19 feet. All right, one final one. What is the approximate difference in the circumference of a circle with a radius of 4 feet and the circumference of a circle with a radius of 6 feet? So I need to find two different circles. One with and this is important, with a radius of 4 feet. So a radius of 4 feet, and another circle with a radius of 6 feet. Okay, we're going to be finding the difference in the circumference. So basically what it's asking is, how much larger is the distance around this circle, the circumference of the circle, compared to this one? I need to know both circumferences. And to find circumference, I'm going to multiply pi, or 3.14, times the diameter. Now I'm not given the diameter, I need to find that. So if I were to extend this smaller circle from not just the radius, but all the way across the circle, it's going to double the radius here, which would give me a diameter of 8 feet. If I do the same to the larger circle and double my radius of 6 feet, I have a diameter of 12 feet. Now I just need to do a little calculating. So I'm going to take 3.14 for the smaller circle times 8 to get a circumference of 25 and 12 hundredths. Now this is in feet because that was the measurement of my radius on the circle here. I'm going to do the same for the larger circle. So I need to take 3.14 times the diameter, which is 12, and that equals 37.68 feet. Now I also want to make sure I've got the same measurement unit here because I'm comparing them. I'm going to have to subtract them, so I need to be subtracting the same measurement units. So I'm going to subtract my larger circle circumference. I'm going to subtract my smaller circle circumference from my larger circle circumference and see what the difference is. When I do that, the difference is 12 and 56 hundredths feet. Again, all my answers are to the nearest foot, and that would be closest to 13 feet when I subtracted these two circumferences. All right. The rest of the questions I would like you to try. Please look back at these three that we did together and use that information as you calculate the questions ahead. Don't forget to round pi to 3.14 for all of your calculations today, and we will continue tomorrow.